I also don't want to fail to acknowledge how much I appreciate you being here. Michael Richards on the far end, they're both class of 2009. You're a systems engineer, is that what you do?
Basically, yes. But I do more software than anything else.
Yeah, kind of applied mathematician, programmer person for Northrop Grumman.
Yeah.
And Tyler is a tenure track professor at OCC, teaching Calculus 3 and Calculus 2 this. So I just want to acknowledge that I appreciate they're here, and now I'm going to get out of the way, and they're going to talk. So, yeah, I'll let you guys hear about it.
Okay, hi, good morning. I'm Tyler. Again, this is Michael. As your teacher said, we graduated in 2009, and we did the calculus project. Actually, in separate groups, we did our own thing. Michael, my project's not here. Michael did the space shuttle you see out there. And then the following year, because of the level of nerds that we are, we did the Lego project just for fun. And then we've basically been here every year since, helping out with this project. So suffice it to say, we like this project a lot, and we think very highly of it. It's a lot of work, but you can get a lot out of it if you put the appropriate time in. Our goal here today is not to give you a rigorous set of steps to say, hey, if you do this, 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 and this, you're gonna have a great project. Because it's really a project in engineering almost as much as it is a project in mathematics. It requires a lot of planning, execution, realizing things you've done wrong, going back and fixing things. And if you view it in that way, you can get a lot out of it. And that's why we like it so much. I mean, it will, as a Calculus 3 teacher, which we do a ton of things in three-dimensional geometry, so the geometry skills, along with the calculus skills you're developing, are really important. But I think almost as important from this project is the engineering skills you take away and the project skills that you take away, if that makes sense, the ability to conceptualize something all the way through to a final product. But if I can offer one word of advice, is everything will take you longer than you expect it to. So you're fortunate that you have a couple weeks before the break to sort of get a lot done, but it takes a while. But you can get a lot out of it. So anyway, I got myself sidetracked there. Our goal here is not to say, here's your rigorous set of steps and you're good. It's to say, here are some tools that we have, tools that we found online, tools that Michael's actually coded himself that will make your lives easier or let you design the project in the way you want. So we have a sort of suite of software that Mr. Bogart's posted on your Canvas page, which you're gonna be able to download. I know a lot of you brought your laptops. As he said, we're gonna go so quickly through it, it would be unrealistic for you to download it now. I think the best thing is to just listen, jot down things if you have them, ask questions if you have them. We're more than willing to take questions. And then we're gonna be here for the next 2 weeks, not literally every day, but most days during your class, and sometimes after school in that last week, here answering questions, because there's just so many of you, he can't do it all himself, frankly. So we'll be here, and we've helped with this a lot. So there's a lot of issues you can run into when you're conceptualizing things, when you're thinking about how is this gonna look in 3 dimensions, and we can help you work through those things and give you some advice. So Michael's gonna take it over, and he's gonna show you sort of what is in the suite of programs we have for you and how to get those up and running. Yeah, so start with installing stuff.
So, like Tyler said, there's this set of software that's broken up into Mac software and Windows software. So I know probably a lot of you have Macs. And they are posted on Canvas. So this is the Mac bundle that you'll see when you download. It includes, I don't know if you guys can see that, but it includes two programs basically. The first is a graphing program, which is, you can think about as a graphing calculator on steroids. And you can use it to plot your graphs, and then with the second program, you can actually print them out. And a lot of you will probably do projects that need to be printed out in pages are larger than a single sheet of paper. So there's this program called PostRaiser that lets you print out on multiple pages and kind of paste them together to get a whole entire graph. Alternatively, you can take it to a professional print shop and print it on a large sheet of paper as well. So I'm going to go over first how to install the graphing program, and it's slightly different between Mac and Windows. So I'm going to do it on Mac because this is a Mac, but I'll also mention what you need to do on the Windows side.
Something to just say really quickly right here. So we've got some instructions here that you can read if you're trying to remember some of these things about how to get this up and running. But if you have a Windows computer, just say it now, there's going to be one additional program here that you need to run in order for the code that Michael works to compile, basically. So you're going to see that third program. The first thing you're going to need to do if you're a Windows user is install that in order for...
Is that in the directions in the read?
Yeah,
It's in the
it's
directions.
in the
It's in the directions. So if you...
Here, I'll open up the Windows side just to show you guys. So there's a program called Python, which is a scripting language that the graph program uses. And you just need to install that first. It's just a normal install file. You just click and follow the directions and install it. And then you can proceed with the graph program. But for Mac, that's not needed. So so graph comes in a zip file. So you gotta unzip it first. And out should pop a application file, which you can drag to your application folder, or you can just open it. So if I open it, so I'll mention now that Graph is it's a Windows-based program, and the reason it can run on Macs is through what's called a compatibility layer. It's just an extra program that lets Macs run some basic Windows programs. So there are some I guess glitches or bugs that make it not quite as easy to use as many Windows applications. But everything still works. So don't feel like you are going to be at too much of a disadvantage if you have a Mac. Right, so this is a graph. It's basically a big sheet of graph paper. And right now there's no grid lines. So I think the first thing you probably want to do is add those grid lines. So if you go to Edit Axes, you'll get a little pop-up that lets you pick what are called a tick unit and the grid unit. And so there's this little box here that says Show Grid. That'll show the grid. Now this is in the X-axis tab, and you'll have to do the same thing for the Y-axis tab. So the way I like to set it up, you don't have to do it this way, but just a recommendation is taking off auto tick and auto grid, and setting the tick unit to 1 is a good tick unit. And grid unit, if you know what thickness or width your slices are going to be, you can put that in as the grid unit, and then you'll get a nice sheet of graph paper that's exactly the width of each slice. So just for the example, if we're using 1/4 inch material, you put in 0.25 from the grid unit, and then go over to the Y-axis tab and do the same thing. And we hit OK. We'll get graphic. And then one important thing is most of the time the scaling on the X and Y axis aren't going to be the same, so it might look stretched out. You can fix that by going to the zoom menu and zooming square. Now,
ready to do Desmos now?
Yeah, I guess.
Okay, so before you switch over, so there's two main pieces of software we want to talk about. This is one of them, and the other one is Desmos. Now, I imagine you use Desmos when you teach sometimes.
I haven't used it for this year. We used it for series in the second semester.
Okay, so Desmos is another online graphing calculator, or an online graphing calculator, as opposed to this, which is a program you download. So it's just desmos.com. Michael's going to pull it up in a second. They both have a lot of really nice uses. Desmos is great because you can pull it up on any web browser, and it does pretty much anything your TI-84 will do and more.
How many people have used Desmos before?
Okay, awesome. So you're exposed to it. So we're going to show you how to do a couple key things in there. There's a few major downsides to using Desmos for this project that we want to make you aware of. The first we're actually going to demonstrate because we're going to try and find best fit curves in Desmos and talk about how you can transfer that over to Graph. The other thing is anytime you want to output anything from Desmos, it's difficult or not doable. Desmos is meant to be an online platform. It's not meant to output to other programs. So you have to think, long term. If you're trying to print out a base area, basically, where you're going to show have the base of your project, you need to be able to print that, and Desmos doesn't let you print to scale in any kind of easy way. So the main things that Michael has coded, there's two things that they're under this plugins tab that we're going to show you in a little bit. And what they're going to do is they're going to let you plot the RAM slices, first of all, and secondly, it's going to let you print easily. Because before, it was very hard to print even in this program. So ultimately what you're going to want to do is you're going to want to print in this. Unless you don't want to print out your graphs, you can always do your graphs by hand. That's when we were in, I hear you sign, but when back in our day, when we were here, that's pretty much what everybody did. And you drew the graphs really nicely by hand, and you picked the person in your group who was better at drawing and had them do it. I imagine most of you are going to want to print, so you're going to ultimately end up using this program. So there's things that Desmos is great for, but ultimately you're going to transition over that. So we're going to show you some of the features of both, and you can figure out sort of how you want to do it and how you're going to develop your shape. So Michael's going to show you some features, and then I'm going to come back and talk a little bit about different ways of designing your project. Because what we don't want to do in this presentation is give you an example and make you think that this is the way to do your project. There's lots of different ways to create the shapes. So anyway, so let's talk about Desmos a little bit, and then we'll get into that.
Okay. Really quick before we move on to Desmos, setting up the axes, you're going to want to, after you set up your axes, I forgot to mention this, you want to click the Save as Default option so that you don't have to re-put it in every time you open up the graph program. So now when you close this, it should pop back up. I'll just reopen it. And yeah, so definitely want to save that as default. Okay, so let's move over to Desmos. So it's if you don't already know, the web page is desmos.com, and you'll click on calculator. So I'll just do that really fast. If you go to desmos.com, you can say start graphing, and it'll pull up a very similar looking, sheet of graph paper that you can start plotting functions on. So the main benefit of Desmos is it's very easy to plot points and do best fit curves, and then tweak the points by kind of dragging and clicking with your mouse. Graph doesn't have that kind of capability, that interactive layer. The other thing Desmos is good at is you can actually put a picture over the graph paper, so you can kind of plot your points over the picture and then do best fit for that. So if you wanted to design your project based on having your base graph be some sort of shape that you find online, Desmos is really good for that. And I'll just show an example of it. So the good old heart example. So I'll just Google heart and find an image of a heart that I like. Maybe this one. Let's see.
So Michael's going to show you how to import it. While he's doing this, I mean, he's just saving it to his desktop, and
Yeah,
he's going to import it, and you're going to see what he's doing. I think this is a good time to caution you a little bit. The sort of standard, if there's a standard way to do this project, is people would find a picture that they want to emulate, and you know, before we had this kind of software, they would actually end up taping it on like the whiteboard and do an overhead projector and start tracing it out on graph paper. And that's essentially what we're doing here with more technology, but you have to be very careful if you're conceptualizing your project based off of the picture. We're showing you that because it has a lot of advantages to it, and it's what probably a lot of it you will end up doing. But when you do things like that, it's how you end up with the Pac-Man effect. Have you talked about that?
I've mentioned it, but I haven't been able to find the picture yet.
Okay, we'll get back to that. I don't want to deviate this too much, but what ends up happening is if you're looking at a two-dimensional graph and you try and just create cross sections, you're not building something in 3 dimensions. You're building something from a two-dimensional picture, and that can create issues. Our personal style when we're doing these projects is to say, what do you want it to look like 3 dimensions? What shapes do you want to have in 3 dimensions? And then from that 3-dimensional object, think about what it would look like in 2 dimensions. So just because we're showing you how to import this picture doesn't mean we're saying this is the only way to do it. You've got to think through that yourself, and we're certainly here to help walk you through that. But proceed with caution when you see a picture and you're like, wow, this looks really cool in 2 dimensions. Doesn't mean it's going to look good in 3 dimensions, right? So it's just sort of a word of caution. So anyway, so he's going to import the picture.
Yeah, so I saved the picture to the desktop. And if you go to this plus add item button here, you can add images to the slide. So let's open the image, and it sticks it right in the middle. And now you have control over where you want it centered and what size you want it. So maybe I say, well, 5 inches isn't really big enough, so I'll make it bigger. Okay, so say you're happy with the size now. So now what you can do is you can add points. So if you go back to the add button, click table, you can add a table of points. And we'll see, just for the sake of example, I'm going to try to find a curve that fits this bottom portion of the heart. So what I'll do is I'll say, okay, well, the bottom tip looks close to -8, 0. Oh, yeah, 0, -8.
Michael, so you went to add table under the main menu?
Yes, that's just add item table. So as you can see here, there's probably a little point down here, and I'll do maybe 2 more. It looks like it could be a parabola. So maybe 5, -5, and 8, 0. Okay, so there's 3 points. And they're not exact because I just kind of eyeballed it. But if you click on this circle and hold, you get the option of dragging. Just drag with the kind of plus sign here. Now what you can do is you can drag these points to exactly where you want them. And this is kind of one of the main benefits of Desmos is you can interact with it very easily. Okay, so that looks pretty good to me. So now what we'll do is we'll try to do a best fit along with these 3 points. So the way you do that is you add a function expression. And if you notice, okay, so the x column is called x1, and the y column is called y1. So the way Desmos works for curve fitting is you write y1, and then you use the tilde, which is like the approximately equal to, and then you type in what function you think it looks like. So I'm gonna try a parabola, just see what that looks like. So we'll do, a plus b times x1. So now it's a line. Obviously that's not a very good fit. So we'll continue on and do c x1 squared. So okay, so now I have a parabola to fit it. And it doesn't quite look right. So what you might want to do is go back to these points, right? And you can see what happens to the plot, to the graph, as you move these points around. And so this is what I'm talking about with it being interactive and being really nice. So okay,
So,
yeah.
so I think this is a good time to mention some things about, finding best fit curves. The temptation that students often have is they'll come and say, oh, okay, I really want to get this curve really nicely, so I'm going to plot a point here, 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 and here. Your project does not have to look 100% like whatever picture you started with. It just has to look the way that you want it to look. So don't feel like you have to fit this line exactly. Maybe you'll use this as an idea and you'll find, hey, I actually created a better heart shape from here. Or maybe you'll say, I'm going to plot just 3 points. Notice, right? He did a best fit parabola. He has an A, B, and C, which means he has 3 degrees of freedom, which means he needs 3 points in order to find an exact curve for it. If you try to do if you only plotted 2 points, this isn't going to work because there's infinitely many parabolas that will go through 2 points. But if you have 3 points, it's going to go through them exactly. It's going to find the parabola that goes through it. If there's 4 points, it's going to find an approximation at that point, right? So by plotting a bunch of points, yes, you're getting the parabola that's closest to that, but it's also trying to fit all of those points as opposed to finding the exact function that you want. There's some style things here about what works for you. Our personal preference when we're doing these kinds of things is not to find the exact function that models this exact picture, but to find a nice function that models something really close to that exact picture. And that's a different way of looking at it, and it's up to you how you want to handle that. But don't feel, again, the theme here is don't feel like you have to do it exactly this way. It's a very useful thing, and I've certainly used it when I did my first project at the very least. But what we may do instead, for example, is we might say, hey, look at this. I think this looks like a half circle. So instead of going through and finding a best fit parabola or something, I'm going to find literally the circle that fits this by figuring out where it's centered and where its radius would be. It looks like -5,5 with a radius of maybe 4 or something like that, right? So you can create functions in ways that doesn't necessarily mean you're finding the best fit. You can develop the functions the way you want. You can think about things like, oh, here I have an infinite tangent line. I have a vertical slope here, right? So I'd like to have a curve that's going to have a vertical slope at that point. And you can use maybe a little bit of calculus or a lot of algebra to make that work. So there's ways you can polish your project that don't necessarily have to be exactly best fit lines. You have to think about what works for you.
Yeah, this is just one example of how to do it.
Are there any questions? I'm more than happy to answer if you have anything so far. Okay. So one of the big restrictions that Desmos has shows up right here, one of the things we're talking about. So you got this nice curve that fits this heart. So for this point, right? And then maybe you're going to start using a different curve from here on out. So you'd want to say, okay, well, I only want to run that from x equals 0 to x equals 9 or something like that, right? If you just type in a normal function, putting restrictions on the domain is relatively easy. You just put x is greater than 0, less than 9, or something like that. You can type it in. But when you do these best fit curves, you can't do that. It's something that doesn't exist in Desmo, and it makes it difficult. There's ways around it, and we can talk individually about that if you want, but it requires like a lot of calling this function and calling that function, and it's fairly confusing. And doing a bunch of these, it would get unwieldy pretty quickly. So this is kind of the stage where we would say you want to start transitioning in the graph. This is the stage where we would say, okay, you can either look at this function that you found, here are the a, b, and c values, and copy those in the graph and do a best fit in graph, or sorry, plug these in the graph and you have your specific function, or copy these points in the graph and do a best fit in graph. But you're losing the power from Desmos about at this stage. Yeah?
Can you change the grid on Desmos?
Yes, so that's under, I believe, the settings here. You have some control over it. You don't have as much control over it in graph as in graph, but let's see. Yeah, I could change the step size, I think. 1.
You're gonna draw your rectangles in graph, right?
Yeah.
So it's not terribly
Yeah, it's
important.
It's not super important.
As long as you're viewing, you know, it kind of depends. You want to think about what material you're using. So if you're using quarter inch, which seems to be one of the more common measurements, then have your tick units be 1 and plot your points accordingly, thinking that 1 refers to an inch, right? If your material is half a centimeter, then your 1 should be in your head as a centimeter, right? But be thinking about that as pertains to you.
Yeah, I guess Desmos doesn't really give you a whole lot of control over how your graph looks.
But that's not terribly important. Can I chime in something?
Yeah.
So the big idea here is, the reason we need 2 programs is, Desmos is good at helping you find the functions that fit your model, but it's terrible at printing and it can't draw the rectangles for you. So that's why you need 2, right? So
Yeah.
you put it in graph and then yeah.
Now we've never used Desmos to do a project before. It's a newer piece of software since we've done a project. So we've always only done it on graph. But again, that goes back to, we didn't necessarily do best fit lines. We created the functions we wanted to model it without doing best fit. We thought about what functions we wanted and kind of built it up that way. So how much you use each tool is going to be dependent upon how exactly you choose to create your project.
And that graph has the capability of doing best fit lines and plotting points, but you can't put a picture over it. You can't play with it on the fly. So
You can't click and drag the
you
points.
can't click and drag the points. Yeah. So there's pluses and minuses of both.
You should transition to the graph.
Yeah, okay. So, and then unfortunately, Desmos makes it really hard to copy and paste functions. So say we wanted to use this function that we found in Desmos, what we'll have to do is type in the parabola that we found by hand into graph, or we can copy each parameter, one at a time. So. I already have the graph open. Okay, so to add a function graph, you go to the function tab at the top and type in insert function, or you click insert function. And you'll get a little pop-up window that gives you a lot of options. Mostly you want to use a standard function that's, a function y in terms of x. And this first bar here is where you type it in. So if we wanted to put that parabola that we found, we would say, okay, well, copy the a, hopefully it paste. There we go. So that's our a plus b times x. Okay, so one quirk about graph is when you do multiplication, you have to very explicitly use the asterisk or the star to denote multiplication. Oh, this window, yeah. So this window is under function, and then insert function. here I have, you know, my b times x, I need to put that, I don't know if you can see, it's really small, but there's an asterisk there.
In other words, juxtaposition doesn't work, you know, like in your calculator, when if you do 5x, it's not gonna realize what you need to do 5 asterisk x.
So I'll do that times x squared, and I'll just click OK, and there's the same parabola as from Desmos. So okay, so if we go over back to Desmos, it looks like we only want this to go from 0 to maybe, what does it look like, 8-ish. So what you can do is you can go back to re-edit a function, you can just double click on it, and it takes you right back to that window. And so the next box down is argument range. You can restrict the domain, say from 0 to 8. And while I'm here, at the bottom you can change, you know, the line color and the width of the line to maybe make it easier to see, or just suit whatever style you want. So maybe I'll make it black, make it a little thicker. So there you go.
Those kind of things would be really nice once you get to the printing stage and wanting it to look nice and try and differentiate between what your curve is and then what your RRAM, LRAM, or MRAM looks like. So you'll want to use that. It might not be enough for everything, but you'll definitely want it eventually.
Would you want a different color for each function? That might be useful too, right?
Yeah, you can do a different color for each. I mean, there's only so many colors they have programmed in there, but yeah, I mean, different. I forget what all the requirements are, but you have to, on the graph, you have to label each function you have. Is that correct? On the physical graph, you want the function
Yes,
label.
yes.
So it might be nice. You have a color like, okay, this color, and then you can type the name of the function or write the name of the function in that color, right? Something like that.
So this,
Will it print out the legend with the graph?
yeah, so as you see here on the top right, it populated a legend that has the function in it. And as they add functions, you know, it'll expand this legend. And the nice thing is, if you go back into the edit, you can actually give each individual line a specific name. So maybe this is the bottom right arc. Now it says bottom right arc, and you can call it whatever you want. So that's one potential way to label functions.
Jump over here.
Yeah. So what I'll do is I have a pre-baked version of the heart, finished heart.
So you keep doing this, right? You do this for